Hello all, welcome back to geometry class. We're going to try this method of videoing today. Hopefully you can see my screen as I do this. So today what we're going to do is we're going to walk through the Unit 8 Day 10 notes. I put them in the folder for the day, so you should be able to follow along with that. And I'll basically walk you through the applications of these triangles. So basically, objective for the day, if you have these printed out, they're going to be able to apply, and we're going to look at SOHCAHTOA again. So instead of just having two real-world problems, so instead of just having a triangle, we're going to have a situation which is going to make a triangle. And I'll get through that. And there's just a couple terms you need to know. So far where we're at in the unit, the first thing we looked at was similarity in right triangles. That's where we talked about your geometric mean information. We did the three similar triangles, the skinny right other. Then we moved into Pythagorean theorem, which was your a squared plus b squared is equal to c squared. And again, we used that to find missing sides. We also used it to classify triangles. That was the converse of the Pythagorean theorem, was used to classify. Looked at special right triangles. Those were your 30, 60, 90, your 45, 45, 90. Again, those were pretty hard. There's a lot of radical work in there that's kind of hard to deal with. Then when we left off with trig ratios. And again, we found ratios. Again, the opposite side over the adjacent for tangent. The other thing we did was we found sides. And that's what the work you worked on yesterday. You were finding sides, as well as using the second button to find missing angles. So we've done all that in Unit 8 so far. So we're kind of continuing on with that. And we're going to look at applications to these right triangles. A couple terms that you need to know, one of which is the angle of elevation. Angle of elevation is an angle made with a horizontal line, and it has to be looking up. So again, the key words there are horizontal line and up. So again, horizontal line and up. So down here I have a picture where I'm going to show you a angle of elevation. So the horizontal line you can see is this line right here. It's basically the ground is making a horizontal line. So now an angle looking up from that line would be from here looking up in this direction. So this creates your angle of elevation, which would be this angle right here. So that is your angle of elevation. And so different ways we could use that. So this one talks about Max is standing 150 feet away from a building, and the angle of elevation to the top of the building is 38 degrees. How tall is the building? So basically what we're going to end up with is a triangle like we're used to. So basically draw the situation. You got Max. I'll draw him as a stick figure here. And then you have a building. So the building, he's standing away from it. I'll draw the building like this. And all of this is going to be on the ground. Whoops, didn't mean to move Max there. So let's see, we'll draw the ground to the building, something like that. So I drew the situation. So next I'm drawing the angle of elevation. So the angle of elevation to the top of the building is 38 degrees. So again, that is from Max looking up to the top of the building here. So that creates this 38 degree angle. So that angle is happening right here because that's where the angle of elevation occurs. Okay, it's made with that horizontal line, which is the ground. So this is your 38 degree angle. Now they did give me other information here. They gave me the Max is standing 100 feet from the building, so that's going to occur between here's Max, here's the building, so this is your 150 feet, which you go right in here. So now what I can do is they want me to figure out how tall the building is. Well, that's the height of the building right here. I'll call it X. So now you can see it sets up a situation. Here's your angle that you're using, your angle of elevation, the 38-degree angle. This would be the opposite side from that. This is the adjacent side. So that means from SOHCAHTOA, I have O and A. So that means I'll be using TOA from SOHCAHTOA. So remember, the T in TOA stands for tangent. And then I put the angle in here at 38. That's going to equal the opposite side, which is the X, over the adjacent side, which is that 150. So remember, now that X is in the numerator, I want to get 150 out of the denominator, so what I have to do is just multiply by 150 both sides. So to figure what that is, you go to your calculator, and I got to do, let's clear this out, I got to do 150 times the tangent of 38. So I press that, I end up with this number here, 117.2. So remember, that's the height of the building. So if I go back to this, I would say X is equal to, where the height of the building is equal to 117 point something. I can't remember what the something was. So go back here, 0.2. And again, that's feet, because that's height of the building. Hey Joe, I'm videoing right now. I can't really talk. Okay? Just come back in a sec. So now there's another problem here. And it talks about Max in a boat near the coastline. Angle of elevation to the top of the lighthouse is 27 degrees. How far is the boat from the lighthouse? So this is a different scenario involving Max. So again, I'm going to draw the situation. So I'll kind of draw a boat. Max is in that boat. So there's my boat, and Max is in that boat, something like that. So there's Max. So now I also have a lighthouse. Is that right? Yeah, lighthouse from the coast. So I'm going to draw a lighthouse the best I can, something like this. So this is basically the same thing as the building. I don't know what a lighthouse looks like. Is that a lighthouse? All right. So now again, the ground is actually water, right? So this is water from here to here. And let's see, it gives me other information. It says the angle of elevation to the top is 150 feet. So 150 feet to the top right there, that is this distance right here. So the 150 goes in right here. And basically that's your hypotenuse, so your right triangle that you can see right here. Other information is I have an angle of elevation to the top. Again, it's always made with a horizontal, so right here, 27 degrees. And what does it want me to figure out? So let's look at what the question is asking here. How far is the boat from the lighthouse? Well, that's this distance down here. That's the distance on the water. So again, I'm going to use the angle and try to figure out what the sides are. This is the adjacent side here. This is the hypotenuse here. So because I have A and H, that means I'll be using Ka from SOHCAHTOA. So remember, C stands for the cosine, and it's always of the angle. So cosine 27, handwriting's pretty bad on this thing, sorry, is equal to the adjacent side X over the hypotenuse 150. So now I got to do 150 times the cosine of 27. So on my calculator, 150 times cosine of 27. Press enter. And that's 133 point, since there's a 5 behind that 6, I have to go with the 7, so 133.7. And that is how far he is from the coastline. What was that again? I'm sorry. 133.7. So that's how far. 133.7. 0.7, and that's in feet. So the rest of these notes we'll look at tomorrow. That's angle of depression. So we're just going to focus on angle of elevation today. And what I'm going to do is I'll give you several angle of elevation problems to work on. That'll be in the folder. That'll be the PDF that you're going to try to do in the folder. So again, once you do that, work on those problems, email me with any questions that you might have on those. They mimic these problems that we've just done. And then I want you to try to submit that by taking either a picture or scanning it on Genius Scan and sending that in as a submission to that assignment. So again, good luck with this. Email me with any questions. And I got to figure out how to stop this. I don't know how to stop it.